Okay, we're going to take a look at the next page in our interactive notebook, which is page 6, the midpoint and distance formula. So please make sure when you fold this page that you can still see the title of this section. So on the front cover, you're going to see the midpoint formula. So notice that we are in the coordinate plane now. So you're going to be given 2 points in the coordinate plane. The first point is going to have coordinates x1, y1. The other point is going to have coordinates x2, y2. And what we're doing is trying to find the coordinates of the midpoint of that segment in the coordinate plane. So you would substitute the values into the midpoint formula and simplify. So your answer should be an ordered pair, because you're looking for the x and y coordinate of the midpoint. The distance formula is the same idea. You still have 2 points in the coordinate plane and you want to find the distance between them. So you're going to name the first point x1, y1, the second point x2, y2, and you're going to plug those values into the distance formula. When you simplify, your answer should be in simplest radical form. So let's take a look at a couple of examples. So if you open it up, the top 2 examples are using the midpoint formula. So we have endpoints RS. R has coordinates 1, -3. S has coordinates 4, 2. So you're looking to find the coordinates of the midpoint, which they're calling point M. So if you want to copy the formula first, this is the formula that you're going to use for number 1. So the coordinates of the midpoint, you're going to have x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. So substituting those values in, you can label the coordinates R, x1, y1, and the coordinates of S, x2, y2. So you'll have 1 plus 4 divided by 2, comma, -3 plus 2 divided by 2. And then you can just simplify this. So 1 plus 4 is 5, so you have 5 halves for your x coordinate. -3 plus 2 is -1, and -1/2 for your y coordinate. If you simplify those to decimals, you may do so. So the midpoint M has coordinates 2.5, -1/2. And that is it. You just leave your answer as an ordered pair. Number 2, we're going to use the same formula. We're still going to look at the midpoint formula. So we're looking for the coordinates of an endpoint this time. So in problem 1, we were looking for the coordinates of a midpoint. This time we're looking for the coordinates of an endpoint. So if you need a visual for these, please feel free to sketch your coordinate plane and plot your points. So if I wanted to just go back to number 1 and do that, just to make sure that I did the problem correctly. It doesn't have to be anything fancy. So just draw in your axes, and then point R is 1, -3. Point S is 4, 2. So here is my segment in the coordinate plane, segment RS. And the midpoint, so approximately the middle, would be over 2.5 and down 1/2. So you can kind of get a visual to make sure that those values match up. And you can visually see that point M does lie exactly in the middle of R and S. So you can do the same thing for number 2 to kind of get an idea of what you're being asked to do here. So again, you can draw in your axes. So point M is the midpoint. So it says the midpoint is M. It's over 2, up 1. So here's point M. Point J is 1, 4. Over 1 and then up 4. So here's J. So we're looking for the other endpoint. So we might have to extend our x-axis here to get a visual. So if my segment is JK, where M is in the middle, then K is going to be somewhere down here. We don't know exactly where just yet. We're going to use the midpoint formula to get those values, but just visually you can kind of visualize where K should be. So now I am going to label the values of the endpoints. So my endpoints are J and K. Now we don't know the coordinates of K, so I'm just going to assign them the values X and Y. And we know that the midpoint M is 2, 1. So you can use the midpoint formula to solve for these values. So you would set it up. Remember, if you need your midpoint formula, you can. So you can easily say that the midpoint is x1 plus x2 divided by 2, y1 plus y2 divided by 2, and that's going to give you your midpoint, which we know has coordinates 2, 1. I already know that. They gave me the midpoint this time. I'm not solving for the midpoint, I'm solving for an endpoint. So I know that x1 is 1, and I know that y1 is 4. So I can go ahead and plug in those values. So now my x coordinate has to simplify to 2. So 1 plus x over 2 divided by 2 has to simplify to 2. And my y coordinate has to simplify to 1. So 4 plus y2 over 2 has to simplify to 1. And then you would just solve this equation for those variables. So start off by multiplying both sides by 2. So now you'll have 1 plus your x coordinate equals 4. So if you subtract 1 from both sides, then the x coordinate has to be 3. Same idea with the y coordinate, although I'm going to move this over a little bit so I have some space here. I'm going to start off by multiplying both sides by 2. So 4 plus the y coordinate equals 2. And if you subtract 2 on both sides, then the y coordinate is negative 2. And then you would double check to make sure visually does that match up. So you'll see that K is exactly now over 3 down 2. So over 3 down 2. So you can visually see that matching up. So those are the coordinates of K, so that when you calculate the midpoint of JK, you would get the midpoint M, which would be 2, 1. So there's your answer. K has coordinates 3, negative 2. So that's your midpoint formula. The two examples on the bottom are using the distance formula. So when it says exact distance, that's when you have to keep your answer in simplest radical form. So just like the midpoint formula, if you want to start by copying this formula down, and then we can go ahead and substitute in values. So the distance equals the square root of x2 minus x1 squared plus y2 minus y1 squared. And that's all under the radical. So then you can go ahead and assign. You are given two endpoints and we want to know the distance between them. So we could say 2, 3 is your x1, y1, and 4, negative 1 is x2, y2. And then you can substitute in. So x2 minus x1 is 4 minus 2. y2 minus y1 is negative 1 minus 3. And you have to perform the order of operations here. So you have to go all the way to these parentheses. 4 minus 2 is 2. Negative 1 minus 3 is negative 4. And then you're going to square those values next. 2 squared is 4. Negative 4 squared is 16. And then when you add them up, you get the square root of 20. Now, if you have a scientific calculator, it will simplify that radical for you. So here's a scientific calculator. Square root of 20 should be 2 root 5. Now, if you're not sure how to do that without a scientific calculator, you want to figure out what perfect square goes into 20 evenly. And the perfect square that goes into 20 evenly is 4. And 4 can go into 20 5 times. So you would simplify root 20 to root 4 times root 5. And since the square root of 4 is exactly 2, I can then simplify my answer to 2 root 5. So that's the exact distance between point R and point S. So you would say that RS equals 2 root 5. And then number 2, for the distance formula, this time we're given the distance. We know the distance is the square root of 53. We are given endpoint R and part of endpoint S. We know that the x coordinate of S is 3, but we don't know the y coordinate. So we're still going to use the distance formula. So you can start out by copying it. And then you can start substituting in values. So if you know the distance is the square root of 53, you can substitute that in for D, the distance. And then you can assign these values just like we did in the first example here. x1, y1, x2, y2. So now when you do x2 minus x1, it's going to be 3 minus 1. And when you do y2 minus y1, it's just y minus 3. And that's all under the radical. Now, notice you have a square root symbol on both sides of the equation. So what I would do is just square both sides. So if you square the square root of 53, you just get 53. And if you take the right side and square it, you just are left with what's inside the square root symbol. So you can get rid of those square roots by just squaring both sides, and it looks a little bit nicer. So now I'm going to simplify the right-hand side. I'm going to leave the left alone for right now. So 3 minus 1 is 2. and 2 squared is 4. Be careful when you're squaring y minus 3. This is like a little side note here. That's like saying y minus 3 times y minus 3. It doesn't equal y squared minus 9, and it doesn't equal y squared plus 9. You have to multiply y minus 3 by itself using the FOIL method. So a lot of people forget that. So you would end up with y squared minus 6y plus 9. So you have to make sure you FOIL. So this is just a little side note when you're doing that, a little algebra reminder. Okay, now just combine everything. You're going to have to put this into standard form. So 4 plus 9 is 13. And then if you subtract 53, bring that over to the other side, you'll have 13 minus 53, which is just negative 40. So you're just kind of putting that in standard form. And then you would factor it. So 2 factors of negative 40 that add to negative 6. So you would use 10 and 4. And it would have to be negative 10, positive 4. So y equals 10 or y equals negative 4. And so this problem has 2 answers. So if y is 10, you'll get that the distance is the square root of 53. And if y is negative 4, you'll get that the distance is the square root of 53. So this problem has 2 answers. So those are the values of y that would give you a distance of the square root of 53.